This video on partial fractions follows on from the first lesson. We're going to quickly go over some of the stuff we did in the first lesson, splitting algebraic quotients into partial fractions. And then we're going to have a look at what we do when we have repeated factors in the denominator. So here's a familiar type problem, one of the easier ones with just two brackets. And you can see we'll get an A over one bracket plus a B over another bracket. So it's going to be one of these four. We just need to find the values of A and B. We've multiplied both sides by the denominator. And this gives us this. We now, because it's an identity, it works for any value of x, we can pick a value of x that will make one of these brackets 0, enabling us to find the other term. So if we make the bracket with the a 0, we would need x to be minus 4. That gives us 7 times minus 4 minus 28 plus 10 on the left hand side, and then on the right hand side this would become 0, so the a term disappears, 0 lots of a, and then we get 1 minus minus 8, 2 times minus 4, so we get 9b. X equals minus 4 there, which gives us minus 18 equals 9b, which implies that b is minus 2. To make the other bracket 0, we would need an x value of a half. We would then get 3.5 plus 10. We would get this bracket as 0, so the b term is going to disappear, and we get a half plus 4 lots of a, 4.5 a. So that implies then that a equals 13.5 divided by 4.5. Well, 2 4.5s is 9, add 4.5 we get 13.5, so a is 3. So we've got plus 3 minus 2, and there we go. Okay, have a go at this one. See if you can remember the technique with 3 linear factors. So you'll have an a, b and a c. You can use the same method for working out the first letter and the second letter, but then need to do something slightly different to work out the third letter. So we'll go straight to this. We start off with x squared plus 1. We've then got a times, and if it's over x minus 1, then we'll end up with x minus 2, x plus 3 when we multiply by the denominator. And then similarly for b, it'll be over x minus 2 initially, so when we multiply by the denominator, we multiply the numerator by everything. The x minus 2 will cancel, but we'll be left with those two. And then finally for c, it'll be over x plus 3, so we get x minus 1, x minus 2 there. So we'll start off by making x equal 1. And that implies then that we've got 1 squared plus 1, 2 equal to, we'll lose this bracket because that becomes 0, so that means this b becomes is all zeroed out. C will be zeroed out because this bracket's 0. So we'll only be left with a times 1 minus 2 minus 1 times 1 plus 3, 4, which gives us minus 4a equal to 2, which implies that a equals minus 2. If we then make x equal 2, then that gives us 5, 2 squared plus 1 up here. We'll lose this term because we get a 0 here, and we'll lose the c term, so we just get the b term, which is b times 2 minus 1, which is 1, and 2 plus 3, 5. So we get 5b equals 5, which implies that b equals 1. The quickest technique for finding the third term, the c term, is to look at how many x squareds we've got. We've got one lot of x squared over here, and each of these brackets will give us an x squared, and we'll multiply it by a, b and c. We know what a and b are. So it's that many x squareds. So we end up with 1 equals, well, a is minus 2 plus b is 1, and it needs to be one lot of x squared, doesn't it? So if we take those over, we get c equals 2, don't we? So we can see there that we've got a 1, a 2 and a minus 2. So the only one with a 1, a 2 and a minus 2 is this one here.